This is the great white shark. It's the largest predatory fish swimming in our oceans today, and it'll happily bite a surfboard in half. It is, by every metric, terrifying. Now, imagine a shark 3 times its size, 10 times its bite force, and one that ate whales for breakfast for over 20 million years. This is the Megalodon. And around 3.5 million years ago, it just disappeared. For a long time, scientists thought they had this one figured out. The oceans cooled, the food ran out, smaller sharks took over, case closed. The problem is, basically none of that holds up anymore. Recent research has completely torn apart the textbook explanation, and what actually killed the Megalodon is way weirder than we thought. So if this animal was the most successful ocean predator in history, what could possibly take something like that down? Before we get into how it died, we need to actually appreciate how absurd this animal was. The Megalodon, or formerly Otodus megalodon, was a shark that grew up to around 60 feet long. To put that into context, that's the length of about 3 great white sharks lined up nose to tail. Its teeth were the size of an open human hand. And these weren't blunt teeth either. They were serrated like a steak knife, designed to slice through bone. The bite force of this thing was insane. Modern estimates put it at over 40,000 pounds per square inch, which is around 10 times stronger than a great white, and around 4 times stronger than that of a saltwater crocodile. To give you some perspective, a megalodon could basically bite a small car in half. And we know its bite force was this strong because we've literally found whale bones from this era with megalodon bite marks still on them. It was just casually shearing through bone like it was nothing. And here's the wild part. This animal didn't just live in one ocean. We've found megalodon teeth on 6 continents. Every warm coastal ocean on the entire planet had megalodons in it. For more than 20 million years. No predator in the entire history of vertebrate life has held the top spot for that long. Not lions, not T-Rexes, not orcas, nothing. And then it was just gone. So what happened? For about 50 years, the textbook explanation went something like this. Around 3.5 million years ago, the Earth started cooling down. We were heading towards the Ice Age. The polar regions started freezing, sea levels dropped, and the warm, shallow coastlines that the Megalodon hunted in started shrinking. At the same time, the whales the Megalodon depended on for food started moving toward colder waters, where the giant shark just couldn't follow. And to make things worse, a new predator was coming up. The ancestors of the modern great white shark were spreading through the same waters, hunting the same prey. They were way smaller, way faster, and they needed nowhere near as much food to survive. So basically the story was, the Megalodon got out-competed, the food ran out, and that was it. This is the version you've heard in every documentary, every museum, every textbook for the last half-century. And to be fair, it's not completely wrong. All of those things actually happened. Here's the issue though. None of it really adds up. The Megalodon had already survived 3 previous global cooling events. It had outlived an entirely different mass extinction 15 million years before this. It had watched continents rearrange themselves. The Pliocene cooling, the same one we keep blaming for its extinction, was not even close to the worst climate event this animal had lived through. So why this time? What made this one different? It turns out the actual answer is way more disturbing. In 2022, a team of paleontologists led by a researcher named Philip Stearns basically broke the entire scientific consensus about what a megalodon even looked like. And it sounds like a small thing, but trust me, it isn't. So here's what scientists used to think. Since the great white is the megalodon's closest living relative, they assumed the megalodon must have been a really big great white. Same body plan, same proportions, just scaled up. stocky, torpedo-shaped, and super muscular. That's what every documentary used to show you. But Stearns and his team weren't buying it. They went back through every preserved Megalodon vertebrae they could find and started comparing the actual proportions to every modern shark species we have data for. And what they found was that the Megalodon was way more similar in shape to a mako shark than a great white. Way slimmer, way more elongated, way less muscular in proportion to its length. Okay, cool. Scientists got the shape a little wrong. Who cares, right? Well, this actually breaks everything. The Megalodon, just like the modern great white, was partially warm-blooded. That's called regional endothermy. It basically means it could keep its body temperature warmer than the water around it, which is super useful when you're hunting in cold water. But regional endothermy is incredibly expensive in terms of energy, and how much heat you can hold on to depends entirely on your body shape. A chunky, stocky shark holds heat really well. A long, slim shark just radiates that heat right out into the ocean. So now picture this. The oceans are cooling during the Pliocene. The Megalodon, with its newly discovered slim body, is hemorrhaging heat into colder and colder water. Every single degree the ocean dropped, the Megalodon had to burn more calories just to stay warm. It wasn't just losing access to prey, its own body was actively turning against it. And those calories had to come from somewhere. So this leads us right into the second discovery, which is honestly even more brutal. In 2024, another research team took these new body proportions, factored in the regional endothermy, and crunched the numbers on how much food a Megalodon would actually need to survive. And the answer they got was kind of insane. An adult Megalodon needed to consume around 100,000 kilocalories per day. To put that into perspective, that is roughly the energy needed in more than a month's worth of food for a human every single day. The only way to actually pull that off is by eating massive, calorie-dense prey on a regular basis. Specifically, whales. The smaller baleen and toothed whales that lived in the warm coastal waters where Megalodons hunted. A single adult whale could realistically feed a Megalodon for 1 to 2 weeks. So as long as the whales kept showing up, the Megalodon was fine. But then the whales started disappearing. As the Pliocene cooling kicked in, the warm water whale populations that the Megalodon ate started fragmenting. Some species went extinct entirely. Others migrated toward colder waters, into the polar regions where the Megalodon's slim, heat-leaking body just couldn't follow, without burning more calories than the chase would even pay back. And this is where it gets really nasty. Scientists actually have a term for the exact moment when a predator's calorie expenditure permanently exceeds its calorie intake. They call it the energy wall. Once a population hits the energy wall, the species isn't dying maybe, it's dying for sure. It's just a question of how long. The Megalodon hit the energy wall, and the clock started ticking. So at this point, you'd think the story is done. Body's failing, food's gone, energy wall hit, Megalodon's cooked. But here's the thing about apex predators. They're way harder to kill than you'd think. Even with a cooling ocean and a starving adult population, the Megalodon should have been able to survive. Apex predators bounce back from population collapses all the time. The only requirement is that the young have to survive long enough to grow up and replace the old. As long as the next generation is making it, the species hangs on. And this is where the third piece of evidence comes in. And honestly, this one is the death blow. Over the last several years, paleontologists have been mapping out what they believe are Megalodon nursery sites. Basically, shallow warm water coastal areas where baby Megalodons spent the first decade or so of their lives. Because here's something most people don't realize. A baby Megalodon was around 6 feet long when it was born, which sounds huge, but in an ocean full of fully grown sharks and toothed whales, 6 feet is basically a snack. The young megalodons couldn't compete in the open ocean yet, so they grew up in shallow protected waters where bigger predators couldn't reach them. We've identified probable nursery sites in what is now Panama, Spain, the US East Coast, and a few spots in the Pacific. And these places had very specific requirements. The water had to be warm because juvenile megalodons couldn't generate their own body heat yet. The water had to be shallow to keep adult predators out, and there had to be enough small to medium prey for the babies to hunt as they grew. During the warm Miocene period, places like this were everywhere. During the Pliocene cooling, they basically vanished. Some of the nurseries just drained as sea levels dropped. Others cooled to temperatures the babies couldn't survive in. And the great white ancestors, the new fast competitors, moved into the exact shallow waters where the young megalodons were most vulnerable. Imagine being a 6-foot baby trying to survive in cold water with a predator that's actually faster than you and that's also going after the same food you need to grow. What the research is essentially saying is that the megalodon didn't go extinct because the adults couldn't hunt. It went extinct because the babies couldn't grow up. Now, here's the part that ties this whole mystery together. Each of these three things on its own should not have killed the megalodon. The cooling oceans alone, fine. The megalodon had been through that before. The competition from great whites alone, manageable. The migrating whales alone forced a range shift but not an extinction. Any single one of these problems was completely survivable for an animal that had ruled the ocean for 20 million years. What killed the megalodon was the fact that all three of these things happened at exactly the same time. The body was losing heat too fast in the cooling water. The calories required to keep that body alive could not be supplied by a fragmenting prey base, and the nurseries that produced the next generation were disappearing. Each problem fed directly into the next. The adults burned more energy trying to stay warm, so they needed more whales. The whales weren't there, so the adults were starving. And the babies they did manage to produce had no safe place to grow up. Researchers studying the timing now think the actual collapse, the final extinction, might have taken less than 500,000 years. Which sounds like a long time, but on a geological scale, 500,000 years is basically overnight. For an animal that had been around for over 20 million years, the end was just sudden. The most successful ocean predator in history got dismantled in less than 3% of its total reign. And the wild thing is, none of it would have happened if just one of those problems had been delayed by a million years. So what's actually disturbing about all of this isn't even the death of the megalodon. It's what it tells us about how apex predators die in general. You'd think that being the biggest, strongest, most dominant animal in your environment would make you the safest. Bigger animals get eaten less, win more fights, and have fewer threats. But it actually works the opposite way at the very top of the food chain. The exact traits that made the megalodon the king of the oceans for 20 million years, the massive size, the high calorie demand, the specialized hunting strategy, the slow reproduction, those are the same traits that made it impossible to save when conditions shifted. A small fish can survive on basically anything. A 60-foot apex predator needs a perfectly tuned ocean to even exist. The bigger and more specialized you are, the more fragile your kingdom actually is. And honestly, this isn't just a megalodon problem. We see the same pattern with basically every massive apex predator that's gone extinct in Earth's history. Dunkleosteus, T-Rex, the giant marine reptiles, all of them died for basically the same reason. The world they were built for stopped existing, and they were too specialized to adapt. The animals that survived these extinction events were never the apex predators. It was always the small, fast, flexible species that could eat anything and live anywhere. The animals that didn't need a perfect world. So next time someone tells you the great white is the king of the ocean, just remember, kings don't last. 3.5 million years ago, the actual king of the ocean ran out of whales, and the world's most successful predator just quietly disappeared. Anyways, thanks for watching. If you enjoyed this one, I have a few more deep sea videos planned that people suggested in the comments. So keep the suggestions coming, and if you haven't seen it yet, check out my video on the sperm whale's clicks.